Good day, everyone. My name is Dr. Oluwafemi George from the Department of Systems Engineering, University of Lagos. I welcome you all to another series of our lecture titled Operational Methods 1. This lecture has been designed to cover different areas of Fourier series, that is, periodic functions, odd and even functions, Dirichlet conditions, half-range Fourier sine and cosine series, differentiation and integration of Fourier series, Parseval's identity, the Laplace transforms and applications, and partial differential equations, that is, methods of solution. We look at separation of variables and the Laplace equation in rectangular, cylindrical, and spherical coordinates. The recommended textbooks for this course include Advanced Engineering Mathematics by Anne Creswick, Mathematics of Physics and Modern Engineering by I.S. Sokolnikov and Rednefer. Fourier series have applications in electrical engineering for signal analysis. That is, it is a mathematical tool used to express any periodic function as a sum of sine and cosine functions, aiding in the analysis, decomposition, and synthesis of complex waveforms and signals. They are also frequently employed in solving physical problems such as partial differential equations and heat transfer equations. Other applications include sound synthesis algorithms and frequency domain analysis in multimedia visualization systems. What is a periodic function? A periodic function is a function that repeats itself at regular intervals. If you take a look at this graph, for instance, we say that this graph repeats itself at p interval. That is, if we move from minus p to 0, 0 to p, and p to 2p. So consider a function f of x equals f into x plus np, where n is equal to plus or minus 1, comma, plus or minus 2, comma, plus or minus 3, comma, and so on. In this case, when it is positive, it indicates the positive x direction, and when n is negative, it indicates the negative x direction. Now, let's look at the average and root mean square of a function. In general, the average of a function is given by y bar is equal to 1 over b minus a, the integral moving from a to b of y dx. This is the average of a function of a function. For the root mean square that we call RMS, the RMS value of y with respect to x for the interval a comma b is given by b minus a y bar bar squared, which is equal to the integral moving from a to b y squared dx. This implies that y bar bar, which is equal to RMS of y, is equal to the square root of the integral a to b of y squared dx divided by b minus a. Even function. A function is even when f of x is equal to f of minus x. E.g., we have cos x, sec of x, absolute value of x. We also have 16 minus 8 x squared plus x raised to power 4, and so on and so forth. So let's consider this sketch. Consider this sketch with interval ranging from minus a to a. This is our y-axis. This is 0, and this is x. So this sketch is defined over a range minus a less than x and x less than a. So from this sketch, we can write that the integral moving from minus a to 0 of f of x dx is equal to the integral moving from 0 to a of f of x dx. And if we want to take the entire interval from minus a to a, so if we want to move from the entire interval from minus a to a, that is moving from minus a to a of f of x dx. So for this to be equal to moving from minus a to 0 f of x dx and 0 to a f of x dx, then we have to introduce this half value. We have to introduce the half. So if we divide, if we call this equation 1, for instance, I'll call this equation 1. So if we divide equation 1 by a, then we have something that looks like this: 1 over a integral of minus a to 0 f of x dx, which is equal to 1 over a, the integral from 0 to a of f of x dx, and this will give us 1 over 2a, the integral of minus a to a of f of x dx. So we can call this equation 2, for instance. So we can see that the average of an even function defined defined over a range minus a to a is the same for any of the three intervals, is the same for any of the three intervals minus a comma 0, 0 comma a, and minus a comma a. So we can say that the average of an even function defined over a range that is minus a comma a is the same is the same for any of the three intervals that is moving from minus a to 0 comma moving from 0 to a and taking the entire interval minus a to a. For an odd function, is a function for which f of an odd function is a function for which f of minus x is equal to minus f of x. So example of this include a polynomial with odd powers with odd powers of x, sine of x, tan, parabolic tan function of x, and so on. And it should be noted that note should be noted that for odd functions that f of x is always equal to 0, that f of x is always equal to 0. So let's take a look at this sketch, for instance, for illustration. So we have this sketch, that is our f of x, and this is our x. So let's have something that passes through the origin like this. So let's say the interval is from minus a also to a here. Then we have the origin here. So for this interval defined, for this sketch defined over an interval minus a comma a, then we can write that if you take the integral moving from minus a to 0 of f of x dx, and this is equal to minus taking the integral from 0 to a of f of x dx, and we know that if we move from minus a to a, f of x dx in this case is always equal to 0. So for this reason, we can say that the average of an odd function the average of an odd function for the interval minus a comma 0 is the negative of that for 0 comma a, and the average for the interval that is minus a comma a is always 0. As you can see from the sketch, moving from minus a to a, if we take the integral from minus a to 0 of f of x dx, it will also always give us the negative when we take the integral from 0 to a of f of x dx. And when we sum the two, that is moving from minus a to a, it results in 0. So the average of the interval from minus a comma a is always observations. The product of two even functions is even. That's observation 1. 2, the product of two odd functions is even. That's observation 2. Then the product of an even and an odd function is odd. And that is the third observation. Also, for either an even or an odd function, for either an even or an odd function, defined over the interval minus a comma a, the root mean square is the same for any of the three intervals. The root mean square is the same for any of the three intervals. That is, moving from the root mean square, what we are saying is that for either an even or odd function, divide over the interval minus a comma a, the RMS, which we denote by y bar bar, which is the RMS of y. It says is the same for any of the three intervals. That is, if we move from minus a to 0 comma 0 comma a, and if we move from minus a comma a. Another thing that we should also be noted is that a function could be even or odd or be a combination of both. That is, if we say if we let y equals f of x, for instance, then we can say y is equal to f of x plus f of minus x over 2 plus f of x minus f of minus x also over 2. So, and this is same as, this is equivalent to h of x plus g of x, that is f of x plus f of minus x over 2 is h of x, and f of x minus f of minus x over 2 is g of x. Where here we know that h of x is even as defined previously, and g of x is odd, since we know that h of x is equal to h of minus x, and g of x, g of minus x is the same as minus g of x. For example, exponential of x can be written as an even and an odd function as exponential x plus exponential minus x over 2 plus exponential of x minus exponential of minus x over 2, and this gives us the hyperbolic cos function of x plus the hyperbolic sine function of x. So we have shown here that the exponential of x can be written as a combination of even and odd function. Again, another example, given that y equals 1 minus x plus x squared in the interval 0 less than x less than 1, show that y bar equals 5 over 6 and y bar bar equals the square root of 7 over 10. Solution. Y, for the first one, we have that y is equal to 1 minus x plus x squared in the interval 0 less than x less than 1. So y bar, which is the average of the function, is given by 1 over b minus a, the integral moving from a to b of y dx. In this case, we know that our a is equal to 0 and our b is equal to 1. So this implies that y bar is equal to 1 over 1 minus 0, the integral 0 to 1 of 1 minus x plus x squared dx, and y bar is equal to x minus s squared over 2 plus s cubed over 3 1 to 0, and this gives us 1 minus 1 squared over 2 plus 1 cubed over 3 minus 0 minus 0 squared over 2 plus 0 cubed over 3, and this gives us 1 over 2 plus 1 over 3, and this is equal to 5 over 6. So therefore, the average y bar is equal to 5 over 6, which is proved. For the second part, we are to show that y bar is equal to the square root of 7 over 10. So now, from our formula, we know that y bar, which is the RMS of y, is equal to the square root of a to b of y squared dx divided by b minus a. So now, if y is equal to 1 minus x plus s squared, then y squared is equal to 1 minus x plus s squared all squared. Let me divide this page into 2. So this implies that y squared is equal to 1 minus x plus s squared into 1 minus x plus s squared, and this gives us 1 minus x plus x squared minus x plus s squared minus s cubed plus s squared minus s cubed plus x4, and this is equal to 1 minus 2x plus 3x squared minus 2s cubed plus x4. Therefore, y bar is equal to the square root of 0 to 1 of 1 minus 2x plus 3x squared minus 2x cubed plus x4 dx, and this gives us x minus 2s squared over 2 minus plus 3s cubed over 3 minus 2x4 over 4 plus x5 over 5 in the interval 0 and 1. And this gives us, of course, 2 will cancel 2, 3 will cancel 3, and 2 here, we have 2 here. This will give us 1 minus 1 squared plus 1 cube minus 1 over 2, 1 raised to power 4 plus 1 raised to 5 over 5. Of course, this minus 0, and this gives us, this we cancel this will give us 1 minus 1 over 2 plus 1 over 5, and this is same thing as 1 over 2 plus 1 over 5, and this is same thing as 7 over 10. Of course, the required y bar bar is now equals to square root of 7 over 10. This is also proved as required. And this comes to the end of this video. Thanks for watching.